morning, everyone. Welcome to the latest GeoTalks Express webinar. My name is David McKittrick. I am Outreach and Training Manager here at Blue Marble Geographics. And as you can see, hopefully, on the slide in front of you, today's presentation is going to be on the subject of planning engineering projects. Now, we're going to involve a couple of our applications, actually 3 of our applications, to create a simulation of this process, this idea of planning engineering projects. We'll be looking at Global Mapper. We're also going to be looking at Global Mapper Mobile and bringing in Geographic Calculator. I know many of you who are Global Mapper users may not be familiar with Geographic Calculator, so this is going to be an opportunity to see how this fits into kind of this workflow, how Geographic Calculator plays with the data that we work with in Global Mapper. For today's presentation, I'm joined by 2 of my colleagues, not just one, but 2 of my colleagues. Jeff Hatzel, one of our product managers, is joining me this morning. Good morning, Jeff.
Good morning, David. Thanks for having me.
Well, great to have you here. Jeff's sphere of expertise is in the mobile place, so we're going to be talking to Jeff, and Jeff's going to be providing some information about how Global Mapper Mobile works in this context. Also joining us is Scott Weber. Scott's sphere of expertise is the Geographic Calculator side. Jeff is our quality assurance manager for that platform. Good morning, Scott.
Good morning. Great to be here.
Yeah, and hopefully collaboratively we can kind of shed some light on this process, the idea of this kind of planning the engineering process. As we noted in the description of this, so that you registered, you saw the description, before you embark on any meaningful engineering work, the planning process is very important, and we are going to be showing how that can be deployed, how it can be worked, how you can work on that within the context of our application. So before we get started, our inevitable housekeeping issues. Many of you I know have been through this before. For those who haven't, this is a webinar. It's a one-way communication process. Hopefully you're hearing us. Unfortunately, we cannot hear you. This is a one-way delivery. That said, we do want you to ask questions. We want to engage. We want to have your input, your comments, whatever you need. Over on the right side of your screen, you'll see a questions panel. You can pop that out, actually make that a little larger. If you have any questions for us, please use that questions panel. We will try to answer those questions in real time as they come in. If there are any questions that require a longer response, we'll take those offline and we'll follow up with you directly. So again, stay in touch. That's your opportunity to engage with this. Now, this session is being recorded. If you have questions and you are watching the recording of this presentation, you can send us an email. I'm going to share that email with you at the end of the presentation. So if you have questions, you can send our tech support team one of your questions. Just make sure you reference the webinar in the context of your question. We'll make sure we give you the response that's relevant. So a couple of items coming up. Well, first of all, our upcoming GeoTalks sessions. Obviously, we do these every month. For the next few months, we've got next month is LiDAR tips and tricks. We're going to delve into some of the LiDAR functionality and maybe expose some of the tools in there that are not as apparent. So we'll offer some suggestions, best practices, I guess, for using LiDAR or point cloud data. We're going to do a simulation of flood analysis, coastal flood analysis, using Global Mapper for our May presentation. And Jeff, I'm assuming you're going to be involved in this one coming June. We're going to talk a little bit more detail about Global Mapper Mobile. I think you are slated to do that one, Jeff.
Mm-hmm.
Yeah, so we will be touching on some of the Global Mapper mobile functionality today. We're not going to go into too much detail. We'll defer to our June session to go into more detail as to how Global Mapper mobile and how the desktop version of Global Mapper work in tandem. Registration is open for all of these sessions. You can go to the website noted on the screen, put your name in there. You'll be given a notification when it's coming up. You'll have your own link to access those sessions as you did with today's. Training classes. We are in the midst of a training class right now. This afternoon, I'm going to be jumping back into my training mode again. We're doing our Global Mapper class this week. Next week, and again, Jeff, I believe this is you next week. You're going to be doing some LiDAR training.
I will, yeah, next week in the afternoon.
March 29th, 31st. I believe there's still some space available in that class if you're interested in taking a 3-day class on everything you need to know about LiDAR. Registration is open. Our next Global Mapper class is coming up at the end of next month. We're doing another LiDAR class early part of May. So if you want some assistance in terms of getting up to speed with Global Mapper, you have opportunities. And Scott, I believe you're going to be involved in this class coming up in June as well, our applied geodesy training, where we're going to look not only at the application itself, but I think you're going to be going through a few of the kind of background principles of geodesy. I think that's how we introduce the class, isn't that right?
Yes, that's right.
Yeah, excellent. So we're going to be touching again on some of those themes today in the context of our content, but if you want more detail on that, registration is also open for that session. I'll just leave the screen here for a second so you can see gistraining.com is where you'll get to that registration information or more information about those classes. So back to today. Again, the idea today is to talk a little bit about the essential elements of the project planning process. And we're going to go through an actual simulation using the applications themselves in just a few minutes. But before we get there, we thought today we would start with a bit of a discussion. What are the essential elements of this planning process? I'm going to ask my colleagues here to turn on their webcams. We don't often do this, but just for this one presentation, we'll get a little discussion going as to how this planning process might be carried out, or what are the essential elements of this planning process. A little bit further down the road, we will be looking at a simulation of a highway project. You're actually seeing a little bit of a screenshot over there on the right side of my screen. So we'll take a look at that in more detail later. But before we get there, let's take a look at some of these important considerations. Well, I'm going to throw this out to my colleagues. What do you think is the most important element of this planning process, guys? What would you throw out as my first consideration here?
Got to be data.
Mm-hmm.
It's got to be data. Well, you guessed it right. Data. One of the important things when looking at any process is the acquisition of data. What data do we have? What is available to me now? Where did that come from? Is it of the quality we need? We're going to get into that in just a second. So the acquisition of data is probably point number one as far as this planning process is concerned. Jeff, this is going to come into your field of expertise a little bit later, the idea of data, where, yes, we have existing files, but there may be some additional data that we can capture.
Yeah, I mean, I think it's important, especially when we're, working on a project of this nature, to keep in mind, how well field collected data can benefit our workflows over what may be publicly available currently. Right? If you're going out in the field to collect data, you have control over, location accuracy, ensuring it's up to date. Right? We want to make sure that if we're working on a project, we're not referencing data that's 10, 15 years old. You have some control over the data quality and making sure that it fits the scope of your project. I don't necessarily need county-wide data for, one highway exit ramp like we're looking at today, right? And then long-term, we think about some of the cost savings that might be associated with being able to gather your own data. I think is always something to keep in mind. There may be a little hardware or software investment up front, but a lot of times then you have the ability to kind of record what you want, when you want it, and how you want it. So certainly something that Global Mapper Mobile allows us to do as well.
Yeah, absolutely. So our project would likely entail a combination of existing data, and we'll take a look at that simulation in a second, and then obviously data that we collect that's more relevant directly for our project. So no matter what project you embark on within the application, acquisition of data is consideration number one. You referenced data standards there a little bit, Jeff, in terms of it's all very well saying we have data, but is it to the quality that would be required for this project? And there's a few bullets. I just threw up some ideas here as to how we can gauge that quality. The age of the data is important. Is it current? Does it contain an accurate representation of the environment we're going to be working with? We often see, especially in areas which are rapidly developing, where imagery, for instance, does not necessarily reflect what is in that environment, and terrain data, the same idea. So we're going to take a look in a minute at how we can access that information, the idea of whether our data is current. When working with raster data, resolution is important as well. Again, is the data of the quality that we need? Are we getting enough information from that imagery? Is it low resolution? Are we not seeing the detail we need? And those are elements that can be addressed and analyzed as part of this planning process. And we'll take a look at some of those situations in just a second. Scott, this brings in your sphere of expertise where we talk about geodetic consideration. I want to have you maybe expand a little bit of this idea of addressing where the data actually resides. Is it in the right location, I guess, is the question.
Sure. Yeah, all of the data that we've got, some raster data, vector data. We want to make sure that all of these are in commensurate horizontal and vertical coordinate systems, which means that we need some metadata from the existing data that we have and hopefully it's accurate, hopefully it exists, whether that be in file headers, well-known text, PRJs, or other metadata. And then in the case of collecting new field data, we need to make sure that we can get that into the coordinate system that the existing data is already in, or bring it into some common system. I was talking to a railroad engineer recently who had data from 2 different states. I believe it was a railroad bridge, and one state had its datum as North American datum of 83, NAT 83, and the other one was NAT 83 2011, a newer realization of that. But when plotted that way, the data did not align. And when taking the NAT 83 2011 data from the one state and just treating it as the original realization of NAT 83, they did align. So there seemed to be a metadata problem there. And that was just something, I don't know how that was ultimately resolved, but it was just a conversation that I had with an engineer that ran into that problem. So making sure the metadata is actually correct is very important. And vertical coordinate systems as well. Are we dealing in ellipsoidal height or North American vertical datum of 88 heights, and so on. So lots and lots of considerations of coordinate systems. That's where Geographic Calculator can best be used. These are the kinds of questions that come to me from customers.
Yeah, and speaking of that railroad situation, obviously that's a very relatable issue. Your railroad lines need to line up. Even an offset of a few centimeters is going to have catastrophic consequences. So yes, that's a good illustration of why this is important, these geodetic considerations. And Scott, we're going to kind of lean on you a little bit later to show us how that process would work. In the world of Global Mapper, where I deal with a lot of data, I don't often pay as much attention to those considerations as I should. Certainly Geographic Calculator is a tool that can definitely be used for that. There's obviously other standards as well that you can assess as far as data is concerned, and again, we'll see those in a few minutes. As part of this planning process as well, once we're confident on the quality of our data, once we have our data and are confident, then the planning process moves to processing and analyzing. Now, I know those are very generic terms. To simulate this a little bit later, we'll take a look at the project plans for this off-ramp of this highway. You're looking again at the screenshot over on the right side of my screen. Creating a story from your data might be a very layman's description of what this entails. Deriving a deliverable product from the data, and we'll take a look at that and take a look at a few outputs that we can generate to make us more intelligent, to give us better information before, again, we send our crew into the field to actually do some real work. This is essential. I should go back, by the way, to the data standards. As we think of the application of this data in our project, if the data standards are not to the required level, everything that comes after, the processing, the analyzing, it's all going to be flawed. So I don't know what bad data in, bad data out, guys. Is that something you hear a lot? I mean, the process might be good, but the data needs to be good to start with. So,
and I think it's important to understand what you need in terms of that if we're talking about geodetic accuracy, right? So in today's workflow, we may need to be, really spot on, but if I'm just surveying a fire hydrant, do I need to know where it is down to the centimeter? Maybe
exactly.
not.
Where is it appropriate? Definitely, absolutely. So and obviously the appropriateness of that is very much relevant to the project at hand. So again, a little bit later, we'll actually show this idea of analysis of our data, and we'll go through some simulations to show how that would work. We're back in the global mapper environment again. Now, the final step in any project would be sharing the data, presenting the project plans. And you'll notice a little pattern here. We begin with getting data in, the acquisition of data, and we end this planning phase with being able to deliver something that represents the plans. That might be the generation of some files that are relevant. It might be sharing a printed map. It may be just here's the print, here's the plan of what we're going to be doing. It could also entail transferring this data back into the mobile platform. Jeff, this might be a situation where mobile comes in again, where you can share the modified project plans, and you can actually go into the field with those.
Oh yeah, absolutely. A great way to kind of come full circle, whatever we had gathered, started to analyze, then what does that look like to us when we're out in the field, and what should we be accomplishing?
Yeah, bringing GPS into play, it puts you in the midst of your data. You can see on the screen,
Yep.
on your tablet, on your phone, where exactly you are. So again, multiple applications come to play as far as this is concerned. Again, we'll simulate this a little bit later. We'll create a couple of output files that allow us to show the project plans that we're working on to our stakeholders, our clients, our customers, our colleagues, maybe even the constituents, the local residents who are going to be impacted by this project. Another part of this planning process, by the way, which is not included in my bulleted list, is obviously financial. It's all very well saying that we have the plans in place to perform this project or to initiate this project, but obviously budgetary constraints are a consideration. Not really relevant to what we're showing you, but it is something that you need to consider. And I know here in the US there has been rumblings of some investment in infrastructure. This talk has been going around Washington for a while, so we know there's some. There's going to be money available for some of these projects, bridge projects, for instance, and certainly highway projects. Long overdue, I would say, in some places. So that is obviously part of this as well. There's no point in planning a project if it comes to a screeching halt then, because you don't have the necessary budget to perform it. So yeah, there's a lot of other considerations beyond what we're dealing with here in a geospatial context. So let's simulate this process. I'm going to turn the cameras off, guys. If you don't mind, let's go ahead and we'll go back and focus on the screen itself. And by way of simulating this, the three of us are going to collaborate a little bit on a workflow here. Now, it is a little contrived. It's a little bit made up. It's not a real workflow, let me stress, but it probably represents a typical use case for the tools that we've just demonstrated. I'm going to bring Global Mapper up. I've got a couple of instances running here. I'll make sure I bring up the correct version. And here we have some data. To kind of put this on a little bit of context, you probably saw a little bit of this information in some of the screenshots in the PowerPoint. We are about to embark on a project. We're going to widen the off-ramp for one of our highways here. And I'm going to turn on some imagery just to give us a little bit of visual context. Again, this is a simulation. Here we have some existing data on my screen. This perhaps came from the DOT. I think it was a CAD file originally, Jeff. I believe you were looking for some data, and this is a DXF file. So the current outline of our roads is represented here, and there's a plan in place to widen this off-ramp. Maybe there's been increased development in this area. A lot of large trucks use the off-ramp, so it doesn't support the volume of traffic. And what we're going to do is simulate the process, some of the procedures involved and the planning involved in widening this off-ramp. As we noted in the previous slide, what do we have to work with? We have our existing CAD file. When was that generated? Is it accurate? We don't know. We are not sure. We certainly can't embark on any meaningful planning process based on this legacy file that was generated some time ago. That's where Scott's going to come to play in just a little bit. He's going to tell us more about those considerations when we embark on this planning process. But probably a more meaningful, a more useful exercise at this stage would be to send someone out into the field to actually do some real data collection. And we're going to send Jeff out. Jeff, I hope the weather's good down there. I think this is Virginia. I hope the weather's going good there, because we're sending you out into the field to do some data collection for us a little better than later. Me. Well, it's not bad today. It's not bad today, but yeah, hopefully a little warmer, a little further down the coast here. So in terms of existing data, sometimes the project planning process just begins with readily available data. I'm showing some imagery here just to give me a geographic context. Again, I'm not sure of the generation of this data. Maybe it's worthwhile taking a look at metadata. Within Global Mapper, we can right-click on a layer and we've access to the metadata. Whatever Global Mapper knows about that file will be noted in this dialog box. Well, obviously, we've got our coordinate reference information in here. This is state plane, as you note. The created date, now this doesn't necessarily reflect when it was flown, but this is a reflection of when the data was actually captured. I downloaded some data. If we were using an online source, we're using a source of data online, we could go right to the source and we could get some information. Is this current? Was this data collected within an appropriate time frame? Also important in the metadata, we noted resolution. This is fairly high resolution. It's 1.9 feet, almost 2 feet resolution. So this is going to give us a reasonable amount of quality in terms of making decisions based on what we see from our imagery. So our first stop here, as noted, metadata. Now I've got some additional data layers here. I've got some terrain data. This was also accessed online. We're not going to go into the details of how that process works. In some of our previous presentations, we've talked about accessing online data. If you want some more information, by all means, you can go back and look at those presentations. There's a wealth of data that's readily available using the online tools in Global Mapper. Let me turn off my imagery and I'll take a look at the same area, but from a terrain perspective, and you can start to see a little bit of the lay of the land. You can see what we have to work with here. It's certainly not flat. There's a lot of terrain involved here. There's going to be a little terrain modification required for this project. I'm going to see that just a little bit later. Sometimes it's a good idea even to pop up this view in 3D. I'm going to dock my 3D view over here on the right side of my screen. So again, we can start to see what's going to be involved in this project. A fairly steep embankment here. We've got a little bit of a hill that we might need to do some engineering. So before, again, we send Jeff into the field, we have a good idea as to what we're going to be working with here. What are the terrain characteristics? The visualization of my terrain sometimes can convey meaningful information as well. Changing my shader to one of the pre-configured shaders called our slope shader will give us a perspective of this area that doesn't represent the elevations themselves, but rather represents steepness of slope. And if I zoom in a little closer, you should note here that the road ramp itself, the existing road ramp, is a fairly flat feature. There will not be a lot of elevation gain in this project. It looks like it maintains a fairly constant elevation, or fairly constant height, which might make our project a little more manageable. We're going to see that a little bit later. So again, we're starting to get into a little bit of analysis here, albeit just visual analysis, but it is an important consideration before we embark on this process. Now, as noted, we really don't have sufficient information to initiate this process from the accuracy perspective that we need. And Scott noted how important it is to determine where your data resides. In order to do that, we're going to first send Jeff out into the field. I want Jeff to collect some data for me. I want him to simulate what the expanded edge of this highway off-ramp will be. We're going to send him out with Global Mapper Mobile to collect that data. Now, Jeff, you can talk a little bit about how that process will work. And certainly, as noted previously, we will be expanding on this in one of our future presentations. But just to show you how the procedure would work, I'm going to open up the configuration in Global Mapper. And right here under Feature Templates, I have an existing template. Now, what a template is the structure for a layer. Jeff is going to go out and collect some point data for me. And you can see here, boundary markers, it's the edge of our simulated highway. I want him to go out and collect this data. This is obviously already created. If I was starting this process from scratch, I would begin by creating a point template. Now, just to show what's going to be collected by Jeff, just a couple of pieces of information I want.
Okay, we've lost David. Jeff, are you there?
I think we may have lost David there, although his screen paused on at just a time for a good segue.
Okay.
What David was saying, did we get David back there for a sec? No, it doesn't sound like it. So what David was saying and showing us here is that before we go out in the field, one of the really handy things a feature template allows us to do is ensure that we are going to be recording the data that we need. Now, right in this scenario, we're only recording, a few bits of information, marker ID, can I get to the marker, and who's recording it out in the field. It's an empty layer, and you'll see me shortly add some vector data to it. David also sent me the existing highway boundary so that I have that for a reference when I'm out in the field. He could have sent me the terrain. Global Mapper Mobile will support and render terrain data, but I don't need that. It's not really relevant to me at this stage of the project. Same goes for the imagery. He could have packaged that up as well, but again, I'm actually going to stream some in live into the application while I'm out in the field, since I'll have a data connection. Exporting to Global Mapper Mobile can be done through a new tool right in Global Mapper. We're not going to get into that today, but it allows you to wirelessly send data from Global Mapper desktop to any mobile device that is on the same Wi-Fi network. So really handy way to get data from desktop to mobile easily. We had a question just come in, as I said that, asking about if we don't want to transfer the data wirelessly or your people are already out in the field. That tool also allows you to, you could export the data locally and email it, file share it, however you need to get it to your users in the field. So there's a few different ways to do that. Let me see if I can steal the screen from David here, even though he's frozen, and we'll start talking about Global Mapper Mobile. So Scott, if you can just confirm for me, we should be able to see Global Mapper Mobile now.
Okay, I see it now.
Great. And so Global Mapper Mobile, I'll expand on the app a little bit here. Global Mapper Mobile is our field data gathering app. As we have alluded to, it allows you to send data from desktop into the field. We're going to look at today recording some data on top of that. And then we will also send that data back to desktop, where both Scott and then David will work with it further on down this project. Again, for those of you who could see mobile being useful to your workflows, we can go ahead and come to that session we're going to have in June to get some more details on the app itself. So before starting any project, I always like to go into the configuration settings for Global Mapper Mobile. The reason I like to do this is there is a wide variety of things that we can address while or prior to a project, I should say. That involves, so some settings here I'll show relevant to this project. What sort of GPS and location information do I want to record? Specifically, I want high accuracy information. What that means in this context is that I am pinging my location services more frequently, whereas if I only did it as needed, the frequency with which I read that location services would be lower, with the idea of saving battery life. So there's that trade-off there. I can also record a variety of location-based attributes as part of my features. And so we'll actually look at those today. When I am recording some points, I want to have that location information associated with those points. There's a variety of more settings in here. We had mentioned we could send a shader to Global Mapper Mobile, or excuse me, a terrain layer. I could adjust the shader in my configuration, and there are a whole variety of other digitizing based settings and things like that to control for our workflows. But for today, I want to make sure I have my accuracy set to best accuracy and some digitizer settings as well. I can see within the app a list of all of the maps that I have on here. So specifically, the one David happened to have sent me for this was called Highway Survey. So I have that stored right on my device. David happened to have sent that to me wirelessly, so it pops up here, no problem. Before I get into opening that map, though, let's go ahead and take a look at setting up our advanced GPS and RTK settings. So Global Mapper Mobile allows us to connect to external Bluetooth GNSS devices. This does require the Pro module, but then you can connect to a variety of external Bluetooth units. And in this case, I used an RTK enabled unit. Within Global Mapper Mobile Pro, we have what's called a N-trip client, and that allows us to connect to a correction source for an RTK enabled device. So what I need to do is enter the parameters for my connection source. In many cases, states have public sources. I use the state's public source. There are private ones out there as well, as some hardware vendors manage. All depends on kind of what your setup is. So in this scenario, I happen to be connecting to a public one. I have control over what specific location I am connecting to, right? So in my state, there are what we call mount points across the state. I happen to choose the one closest to me, but I have full control over what I connect to. And then I can see any details provided by this service as well. So I can see, you know, its name, data formats, what sort of information it's providing, and things like that. So that I have that as part of my workflow and my data, or what will become my metadata. I'll get an alert saying that connection was successful and telling me the unit that I'm connecting to. I happen today to be working with a Javad Triumph 2. Once that connection is established, I always like to take a second before getting into my workflow to look at the information that's coming from my device. And so this is all raw information we are pulling directly from the RTK unit that I'm connected to. So I can see information regarding my location information, so my latitude, longitude, my fix type, right? So I have a RTK fix, which is, you know, what we would want here in this scenario. It's the highest level of RTK connection we can have. My confidence information for my vertical and horizontal accuracy information, and we can see that down here as well. I'm not really moving in this instance, right? I'm standing still, so, you know, 0.2 kilometers an hour. And then also status information from my RTK connection. So I can see that it is sending and receiving information. We'll talk about recording that information in a second, and I can see how many satellites I'm connected to, and some other information associated with that as well. I can view my satellite constellations and you know, toggle these on and off if I needed. So if I only wanted to see GPS or GLONASS, or, you know, whatever constellation that my device connected to, I can toggle that here as well, along with, you know, an expandable list of the signal to noise for each of those satellites. I had mentioned being able to record the NMEA stream. We can also view it live. So this would, you know, if I had this running live, this would scroll live as the information came in from my external unit. I can record it in the background as well. So if I chose to record down here, that would run in that could run in the background while I worked, and I could save that out as a text file. This is usually fairly important to have if we're doing anything that comes down to something that ends up being a legal document or legal usage, so that we have reference to that raw information. So always something that we want to be aware of. If we need to record that, we can record that as we're working. Okay, so once I open the map that David sent me, what I see on screen is really just a representation of the vector data of the existing road boundaries. The only other data that he sent me was the feature template layer, and that has no data in it yet. I will be recording data into it. So that's what we will be populating as we go. A couple things I'll point out on my screen. I have some optional things displayed. So I have a compass on, and I have a little shortcut bar, just a really easy way for me to get into and out of some of the location settings, along with a little indicator. So I like knowing a little reassurance that my Bluetooth is still connected. I'll pause for a second here. We had a couple questions come in. I'll try to answer at least one here as we're moving along. Somebody asked if they could explain what kind of accuracy we would expect in Global Mapper Mobile. And so that is always going to depend on the external units that you're working with. Right, if you're just using the phone's internal location services, you know, cell phones usually get about plus or minus 5 meters, so not really great for high accuracy work. This question was asked in relation to the Triumph 2 that I happen to be using. I don't off the top of my head recall what it's rated at, but usually those RTK units are, we're talking, you know, centimeter level accuracy, and I've seen that myself out in the field. So in general, if you're using an external unit, I would say, you know, refer to their documentation and specs. We're just pulling the information in from them as raw data, so we will report whatever that device provides. So what I would like to do here is give myself a little bit more of a reference of where I am in the field. Just for visualization purposes, I want to add some imagery. And since we didn't have David send that to me from desktop, I can connect to a variety of built-in online data sources in Global Mapper Mobile. So this will be very similar to, for those of you who work with the online data tool in Global Mapper Desktop, it's essentially a pared down version of that list. And if you're someone who works with custom online sources, you can add those in manually as well. I'm just going to connect to an imagery source here, and then we'll see that now as my base map on display. Worth noting, I could save and export this. Essentially, it would save it to my phone, to a Global Mapper Mobile, and I could use it again if in the future perhaps I am not connected to a network when I'm in a given location. So you could work some semblance offline. Now, when I go ahead and enable location, so I had connected to my external device earlier, and now I'm going to enable it within the app so that I'm actually reporting that information on screen, and I can use it to create features. So on the screen, I'll get a very basic report of my location information and some accuracy information to go along with that. If I needed to see more, I could always go back into those location information settings that I showed earlier. Once we have our location enabled, we have a variety of ways which we can create features. Today, I'm just going to record points, so that's the menu we're looking at here. But we could also record lines and area features. Regardless of the type of feature we're recording, we can do so manually based on a variety of GPS options. You know, for points, we can record pictures, and strike and dip, which is a geological measurement. So a variety of different ways to record data. What we're going to do here is I'm going to use a GPS tap, so that whenever I tap on the screen, a point will be created at my GPS location. When I tap and make that point, we'll see that based on my settings earlier, all of the location information that's being provided from my external unit is saved as attribute information associated with that point. So going back to that question on accuracy earlier, you'll be able to see all of the information provided from your device. And that'll be a larger list. You know, right now I'm not getting everything from the device, and that'll vary device to device. And I will also be prompted to populate the 3 attributes that were part of the feature template that David had sent me earlier. So if I tried to exit out of the screen without populating these, I would get an alert that I need to populate that information. As I move on to continue recording points, and what I did was there were, you know, survey stakes out in the field, and I walked along each one to record the locations at them. As I move from one to the other, I always like to just pop into my location info screen, make sure I'm seeing information, you know, relative to what I expect as I'm moving along. But then other than that, you know, I would walk through. I'm not going to show us collect every single point out in the field today, but I would walk along, record those points in the same manner, and we'll show them here, you know, when I completed that work on the map. So as I moved along to each survey stake and recorded a location for them. Each of those is saved into that feature template layer that we showed earlier. And at this stage, I would send those off to back to the office for further work. In this case, I'm going to send those over to Scott shortly. Now, again, I could I could email this, use, any file sharing service, Google Drive, Dropbox. I had my Nemea stream being recorded in the background, and I could send that the same way. So Scott, if you're ready, I'll go ahead and give you the screen.
Sure.
And you can talk to us a little bit about the work you did in Geographic Calculator.
And
Okay.
while those guys are going through that process, with apologies for leaving so abruptly earlier, internet access issues, just to clarify the data flow, and we will go into more detail on this in our future session, but ultimately, Jeff, your data is going to come back to me. It would give me an opportunity to see what you've done, and then I'm going to send that to Scott in a format that Geographic Calculator can work with. So that data transfer from the field, it goes through Global Mapper, that brings the desktop application back into play again, and then obviously the formats that Global Mapper support can be used within Geographic Calculator. So we'll assume that process has been done. Scott, why don't you tell us about what you're going to be doing here within the calculator?
Okay, let me just confirm you can see my screen.
Yeah, we can, yeah.
Okay, great. So you're likely to come to a point where you need to transform or reproject some of your existing or field collected data. And in some cases, your GIS may have the necessary projections and transformations, but in some cases it may not. And this is more likely the case when time-dependent observations and transformations or vertical transformations are required. So in these cases, Geographic Calculator becomes very useful because its data source, its library of projections and transformations, is an extensive set of horizontal and verticals, including time-dependent transformations. And we're going to exhibit one of those today. In our Virginia Highway example, we're going to use the National Geodetic Survey's HTDP tool, that's horizontal time-dependent positioning, to transform Jeff's field collected points into the same coordinate system as the other project data that we have. Now, I'm not going to go into every single data set, the raster, the elevation, DTM, the imagery, and the existing DXF all had to be brought together into one coordinate system and datum. Some of it was ready to go. Some of it I already did some work on. I'm just going to show you one example of how to do that process with Jeff's field collected data today. So the coordinate system we're targeting is the state plane Virginia North on the 2011 realization of the North American datum of 1983. Mouthful there. We're going to include time dependence here. So we have a collection time for the Jeff's field collected data, and let's just assume that the metadata gives us some information about the collection time, when the imagery was taken, and so on. And what we're going to do is assume that it's all current, and I'm going to just use a date of March 1st of this year to do the transformation. For that same date for the source and the target. That's still a time-dependent transformation, even though the dates are the same on both sides, because the transformation has velocity files that they adjust the transformation parameters based on the difference between the source and target dates or epochs and a reference epoch in the transformation. So even though they're the same dates on both sides, those dates are different than the reference epoch, so it is a time-dependent transformation. So let's take a look at the calculator interface. When you start it up, you'll be greeted with the start page, and calculator has 13 different job types. And in the start page, I can click on each of these types and it'll tell me some information about what that job does and what kinds of input and output is supported. So for instance, this interactive conversion job is for manually converting individual points. And it's manually typed in, and then you get an output, and you can do a couple of things like that. Write it down, view it in Google Earth, or save it as a shapefile as a single point. Point database conversion is a job that handles tabular data or spreadsheet data. And there's a variety of spreadsheet tabular formats for input and output. There's a raster job, a vector job that we're going to use today, and then there's some specialty jobs for handling seismic data, area calculation, and a few others. On the left-hand side over here is the project manager. And by default, there is a project that contains one of each of the 13 kinds of jobs. And I'm just having that collapsed for now. And I've created an additional project named Virginia Highway Project, in which I have added one of the vector conversion type jobs because I've been handed a point shape file. So that's a vector format that I want to convert to back to, in this case, the same vector format, but transformed and reprojected. So I've already loaded in the input data that David has handed Jeff collected in the field and went to Global Mapper, and now it's come back to me as a shapefile. And you can see a small preview of those points. And on the left, I have the source coordinate system, and it's already set up to ITRF 2014. It's geodetic data, so the units are degrees. I've entered the date of March 1st, 2022, and this is a three-dimensional shapefile. It has a vertical coordinate system of ellipsoidal height. So that's the ellipsoid of ITRF 2014. And the units for the vertical are meters. Now on the right-hand side, you can see what is just the default setting for coordinate systems, WGS 84 with no vertical. So I need to set that properly for what I want. So I can double click on this system box area that's in dark blue right now. I'm going to double click that. And it brings up a selector. And I want a projected coordinate system. So I'm going to go to projected over here in my menu on the left. North America, United States. And I'm looking for state plane coordinate systems. And I'm going to be in the NAD83 family. So I open that up. And then specifically, I want the 2011 realization of NAD83. These are alphabetical. So I'm going to scroll down to Virginia. And I want the Virginia North state plane system. Notice there's two here. One in US survey feet, and this one unlabeled happens to mean that it's in meters. As of the 2011 realization of NAD83, metric is a valid unit. So they still have the survey foot version, but there's now a version in meters as well. And we're just going to go ahead and use that one. Fills in the geodetic with the correct datum. There's my date, March 1st. Now it shows indeed that my units are meters, so that is correct. And now I need to set the vertical. So I'm going to double click on the vertical box. And now I want to go to North America, United States, and I'm going to widen this out a little bit, North American vertical datum of 1988. You see there's several selections here. There's some heights and there's some depths. We're working on land, so I'm going to use height values, and I want to use the metric version. So that is the one that has no unit attached to it. You can see there's international feet and US survey feet are available as well, but we want the metric one. And I click OK there. And indeed, my unit shows up as meter there like I want. So my source and target coordinate systems are set. Now I need to select the coordinate transformation to get between those two. So the box in the middle, labeled coordinate transformation, I double click that. And here's my selector. As I mentioned, I want to use a time-dependent transformation. And it's a very long name here because the the HTDP converter, what happens is once you enter those dates and source and target coordinate systems, it generates a custom based on all that information. And so it's piled all that information into the name. We'll see that in completion in just a minute, but I can see over here under type that it's the HTDP converter that I want. I'm going to click next. And now I'm going to select the vertical transformation I want as well. So this is an added feature of Geographic Calculator, is that we can do vertical transformations between datums. And we're going to assume here that I have information that the NavD88 data that I already have, the digital terrain model, was converted to that, arrived at that through the US Geoid model of 2012B. Okay, there's a lot of geoid models. There's actually a newer one, the model of 2018, but we'll just use 2012B in this case. And I tried some of these out in advance, and I know that this one is going to work out well for us. So now the job is completely set up. All that's left is to enter an output file name, which I've already done, a rather lengthy name, but very explicit about all the coordinate systems and units involved. And then I can process it. And over in the project manager, there's an indicator that it finished. There's also a messages window down below here that gives me some details about how that transformation went on, if needed. And so now that shapefile that I just created is ready to send back to David for him to do his magic in Global Mapper with some great analysis. So take it over, David.
Yeah, magic. I like the word magic. That works. Yeah. So again, recapping, Jeff collected our data. There was a couple of questions came in relation related to why we needed to go through this if Jeff collected data in the field. Well, obviously, we want to make sure everything is in the same reference system. Scott, we didn't actually go through these procedures, but the imagery we're working with, the terrain data we're working with, is important that that's also in the same system. Calculator does support processing terrain data as well. So maybe we're not going to talk about that in detail now, but that would have been something you would have done previously. So we're basically all on the same platform now. So let me go ahead and grab the screen back. And I know we don't have that much time, but let's take a look at the process. Wrong screen. Let me try that one more time. Make sure I'm showing you the right screen here. Just give me a second. And there we go, that's better. Again, with apologies for losing connection a little bit earlier. Hopefully that transition still worked. Jeff, thanks for taking over. We're back in Global Mapper again. We started with Global Mapper, initial data visualization, what data we have. Now we're back in Global Mapper again. Jeff collected the data. Scott processed it. We know that data is accurate. I have those points. I have the points that Scott exported. I've rendered them here, just giving them a yellow dot so they come out clearly. In order for me to simulate this actual construction project, and we're going to do this very quickly just to show before we wrap up our session what we can now do within Global Mapper. I want to create a simulated surface representing this expanded area. I have very precise points here representing that right edge of that what would be eastern edge of my off-ramp here. First thing I'm going to do is I'm going to convert those to a line. I want that to be a line feature. Very simple process. I'm going to first select them all. They're all highlighted here. All of these points are highlighted. And using one of the simple digitizer tools in Global Mapper, I can create a line. I'm just going to right click, go into my digitizer tools under advanced creation options, and you'll note here, create new line feature from selected points, connecting the dots effectively, giving me a precise outline for what that modified surface is going to look like. I can define a threshold between my points if that's appropriate. It's not relevant in this case. I'll just click OK. I define the name. I'll just call this right edge, just so we can see it in our control center. Right edge, and I'm not worried about any other attributes at this stage. Obviously, we could populate this with additional information as relevant, and we'll just click OK. And the points have served their function now. I now have that line feature, that outline of the surface that we can build out to that point. That is accurately surveyed by Jeff. Again, I know I'm cutting a few corners here in terms of how this process would work, but now what I want to do is simulate what that modified surface will look like, and by way of doing that, generate some volumes. How much material are we going to need for this? How much engineering is going to be required? For this, I'm going to need my terrain data. I'm going to turn that layer on. Now, this is my existing terrain. Again, Scott has processed for this for me. I know this is good. This is accurate. It's in the same system as all of the other data. Turn off my base map so we can see that terrain data. And you can see I'm using the elevation, the Atlas shader here to visualize my terrain. I'm going to turn off my original outline, what we derived from our DXF file, basically the data that Jeff took in for visual reference, took into the field. And you'll see here I have the outline. Now, again, I'm cutting a few corners here just in the interest of time, but I've generated a polygon that incorporates the line I created with the existing left edge of the road. And you'll see that now represented as a polygon. It doesn't, well, it has, by doing that, inherited the elevation characteristics that are in the original. I've modified those for this updated surface. What I'm going to do with this simulated area is to create a modified surface. I'm modifying the edge, and I'm going to do that by first selecting the polygon. I'm going to right click. I'm going to go to advanced feature creation options, and all the way at the top here, towards the top, is the option to create a flattened site plan grid. Now, this is very often used for construction sites, but it also, in this context, will work for this road alignment. It'll create a localized road for me. I'm going to choose that option. Few settings I can apply here, not going to go into the details, but I do want to use the existing heights within that vector feature with a per 30% slope around the edge, and we can click OK. Now we're going to get two outputs as noted here, and this, again, being part of our planning process, this is a very important report. This tells us for this expanded highway, we're going to need just over 8,000 cubic meters of fill. We're going to remove a little bit as well, that being towards the bottom of our target area. There's a little bit more cutting that will need to be done, so about 342 cubic meters there. So before we send our crews out into the field, we have a fairly good idea as to how much engineering is going to be required for this. That report, or that output, can be copied and pasted into the report. I'll click OK to finish this. And as an ultimate output, we do then get a modified surface. You can see that expanded surface now. I'm going to turn off my original vector so we can see a little more clearly, and you can now see what that modified surface will look like based on the parameters that we applied. We can also generate a cross-sectional view of this. In fact, we could do multiple things, multiple cross-sections from a perpendicular perspective. But just for illustration purposes, I'll create a single cross-sectional view to show that what that would look like. And based on one of the settings I've applied, you can also see what the original surface. Now, this is a little bit exaggerated in terms of the vertical scale, but you can see what this cross-section will look like now with our new surface, the original surface. And again, we know based on the calculation we applied previously how much of this material we're going to have to remove, or how much we will need. I think if I go a little further to the south, we're going to get a little bit here where we actually need to adjust our embankment here. We need to move material to accommodate that wider shoulder there as well. So we can get those visualizations. We could generate contours. We could visualize this as a 3D model. Now, again, we're running out of time very quickly here. A lot of the functions that now come to play are tools that we have introduced you to in previous presentations in the context of introducing the terrain analysis. Now that we're in this project planning phase, we can apply these in this more realistic context. Final thing I'm going to do here is bring in some LiDAR data. LiDAR data, obviously, available locally for this area. We could have used this as an initial analysis of our terrain. We could have generated our own terrain model. I'm going to filter my LiDAR to leave just the vegetation points. And this is going to give us an opportunity to show the visualizations at the end. I'm going to uncheck all. I'm going to retain just my high vegetation and turn everything else off. Now we're seeing what the trees look like. And you can see, as part of this planning process, we need to do a little removal of vegetation to accommodate this. And if I pop up my 3D view, we can see this even more clearly. If I dock this over on the right side, we can see what that looks like, the removal of our trees. In order to initiate this, I'm going to conduct one final procedure, one final analysis based on the LiDAR data. I've brought up the center line. Again, I could have created this using a tool in Global Mapper called the skeleton tool. Generates a line feature in the center of a polygon. Here's what we have for our center line. And I'm going to use this for a proximity search. I'm going to select all my LiDAR within a certain distance of this center line, and these points obviously being my vegetation points, and simulate what this will look like when we remove the vegetation, and giving us an idea as to where we need to deal with this encroachment. This tool in question is one of our LiDAR tools. Select LiDAR by distance, and again, without going into the details, we define a distance from my center line. We can use that as a 3D distance, not relevant in this case. We define which points we want to target. In my case, it's my high vegetation points, and near my selected line is the final option here. And hopefully, if everything goes according to plan and I click OK, 15,000 of my points are going to be highlighted here, and you can see those clearly represented. Simplest way to visualize what the output of this will be, the outcome, I can hit delete on my keyboard and it removes those points. Now looking over at my 3D view, I can get a clear indication of what the new terrain will look like, what the new road surface will look like. We'll turn off my center line, and we can see then the results on the vegetation. And certainly with a lot more space for those large trucks as they're progressing along. Now, obviously at this stage, we're getting back into the visual representation of my data. Being able to share this, that was our final bullet, if you recall. I could export these files. I could export this terrain layer to a new DEM file to be shared with our stakeholders. I could generate Global Mapper package files to share with other Global Mapper users. Jeff, I could send this back to you again as a GMMP file, so you can take this into the field in Global Mapper Mobile on your phone, on your tablet. So multiple ways of sharing this. One of the really cool ways is through the creation of what's called a 3D PDF. If we want to engage with the local stakeholders, this is a good way for them to get access to the project plans in a visual way. And from off screen, I'm going to drag into view what that looks like. You can see a little bit of a difference on my terrain surface here. But this is now a PDF file that represents the modified surface, my terrain area, as well as my LiDAR data. So again, my stakeholders can see the output of this. I'm just tilting around a little bit on my 3D PDF, and you can see that updating. I'm not very good at navigating here. So this is a great way for me to share a report of what this plan will entail. We have the wherewithal, we have the calculated volumes, we have the visual representation. We now are confident that we can go into this project with the information that we need. Anything to add, guys? Did we complete our planning process? We overshot the top of the hour by just a little bit, but we all played a part in this. All of our applications played a role in this simulation. Geographic Calculator for our geodetics, obviously for our data collection, Global Mapper Mobile, and the beginning and end of the process, Global Mapper itself.
Yeah, absolutely. I think we hit on everything pretty well.
So let me bring back up my trusty PowerPoint here and just go back to where we started. We outlined the elements, hopefully we illustrated those during our simulation, acquisition of data, then addressing the data standards. Scott was instrumental in that process in Geographic Calculator, and then a little bit at the end to show some of the processing and analyzing and sharing our data with our stakeholders. Thank you for attending today. We really appreciate you taking the time. Again, I have to apologize a little for losing connection a little bit earlier. Hopefully the transition went okay. Hopefully Jeff was able to pick up. It sounds like he was.
It was a good spot, you know.
Good spot, good, I'm glad. I think I've been talking too much. This is the technology's way of telling me to shut up. So, intaken. Thank you, Jeff. Thank you, Scott. You guys have a lot to do on a daily basis. I'm so glad you took the time to share your expertise with me. We will be hearing from you again, Jeff, a little bit later when we go into more detail in Global Mapper Mobile and one of our future presentations. I just want to remind you one more time about training. If you are interested in any of these tools, we went through them very quickly, obviously, but we have training coming up that will obviously give you an opportunity to explore those in much more detail. Spaces are still available in our training classes. Go ahead and look at the Global Mapper or the Blue Mapper website, and you'll get information about that. Thank you, folks, for taking the time today. We will be back next month when our topic will be on LiDAR tips and tricks. Have a good day, folks.